The central question in this study is about curiosity. So we are interested in what makes us as a species so curious. Why do we want information about the world so badly that we're willing to pay money or resources in order just to get extra information? Curiosity, it turns out, is something that we know almost nothing about. This is a branch of psychology that didn't really even exist 10 years ago, and it's really just in its very early stages.
Do we want to separate?
Somewhere around, yeah, we don't want 14.0.
Okay.
So we're going to look at brain activity in monkeys making decisions. Monkeys are being a model for humans in this study. While the monkeys are making these decisions, we're going to see what's happening, especially in the reward circuitry of their brains. And this study is focused on one of those areas called the orbitofrontal cortex, which we think is a very early stage on this hierarchy. And we want to look at what's happening there while those monkeys are playing a little video game.
The way the task worked was that we had the monkeys choose between two gambles. And regardless of which one was chosen, there would be a delay between when he chose that gamble and when he received the reward. The yellow indicates how big the reward will be if the monkey chooses that and wins. And what we did was had one of the two gambles be an informative gamble. And what that means is if he chooses that, he finds out immediately whether he won the gamble and is going to receive a reward or not. The other one was uninformative. And what that means is after he chooses that, he's not actually told. So he just has to wait. And so he's going to be curious during that period. On some trials, the reward that the monkey will receive for the informative option will be lower than the reward he might receive for the uninformative option. So on a trial like this, the monkey has to make a trade-off between receiving that information and receiving the larger reward. Monkeys strongly preferred the informative gamble. They'd choose it around 80 to 90% of the time.
One of the new discoveries that we've made in doing this study, along with our colleague Ethan Bromberg-Martin at Columbia University, is that monkeys are curious in a lot of the same ways that humans are curious. Imagine that you buy a lottery ticket at 10 in the morning. You want to know whether you're going to get that money or not right away. And you might even be willing to pay an extra 50 cents just to get that information sooner. Or you might prefer the scratch-off lottery ticket that's going to give you a more immediate gratification. You're not going to get the money any sooner, potentially. You're just going to get that information sooner. And that's the logic of the task that we designed for these monkeys.
We had this estimate of the subjective value that the monkey placed on information. And so what we could do with that is that we could look at how neurons responded and see if they signaled that exact value.
We're going to look for the value of the juice that's available to the monkey in the task, and we're going to look at the value of the information. That's the curiosity itself. And we're going to see both of these signals present simultaneously in the activity of the neurons, but not yet integrated into a single whole. One of the reasons this research is so important is because this basic desire for information turns out to be something that's really corrupted in people with attention deficit hyperactivity disorder, ADHD, also depression and obsessive compulsive disorder. So we think that by understanding these basic circuits in the monkey with this very simple model task, it's actually going to give us information that will 5, 10, 15 years down the road lead to new cures for these psychiatric diseases.